What's good, everyone? This is Algebra 1 with Mr. Peters. Today, guys, we are going to be talking about systems of equations, and I'm going to show you guys how to graph a system of equations, and we'll talk about the different type of solutions. So when we're looking at line A, I'm going to choose to graph by intercepts because of the way it's set up. So what that means is I'm going to make one variable, I'm going to set one variable equal to 0, and I'm going to solve for the other. So when I solve this first equation for x, I'm going to get 3x is equal to 6. And after we divide by 3 on both sides, we're going to get x is equal to 2. And what I'm going to do is I'm going to go and plot that point on the graph. So we go ahead, we plot our point at 2. And now we're going to go back to our equation and we're going to solve for the other variable. So now, same equation, I'm going to make my x 0. So we have 3 times 0 plus y is equal to 6. So when I solve this second equation and I solve for y, I know that the intercept is going to be 6. So we're going to go on the y-axis and plot that point. Okay? And now what we're going to do is we're going to get a line on this graph. So we get our line on the graph that's going through both points the best that we can. Now what we're going to do is we're going to go back and we're going to solve for line B. I'm going to do that on the right side of the graph. So same thing, right? We have 3x minus 0 is equal to 6, right? Substituting 0 in for the variable y. And what we get now is 3x is going to be equal to positive 6. Now, for us to solve, we're just going to go ahead now and divide both sides by 3. And we'll get that our answer will be x is equal to 2. So now what I'm noticing is both of these equations share the same x-intercept. So I'm just going to highlight that because that's important for this lesson. And now what I'm going to do is I'm going to go back and I'm going to solve for y in blue. Let's try blue so it could stick out. So now we have 3 times 0 minus y is equal to 6. So now we have negative y is equal to 6. So just understand that that subtraction sign is in front of y, so it makes y negative. So after we multiply 3 and 0, do not drop that subtraction sign. It stays in front of y because y is negative. However, the issue is, guys, we cannot have a negative variable. When a variable is by itself like this, it can't have a negative sign. So we're going to go ahead now, and we're going to go in black, and we're just going to divide both sides by negative 1, right? So now what we're going to get here, our variable is going to be positive, and now 6 is going to be negative since we divided by that negative 1. All right, and we'll go ahead and plot that point on the graph, negative 6, and we'll go ahead and plot 1 on 2. All right, so now we got the x and y intercept for our line B. We're going to go ahead and graph it now. So we're going to use our tool, and we're going to go and see if we could get a nice straight line through both of them. So after graphing, guys, this is the very important part of systems of equations, understanding the solution. So all the solution is saying is the point of intersection when we're talking about graphing. So if you look over to the left, we're going to highlight the 3 solutions. So the first solution is one solution. That means that there's only one single point that satisfies the equations. Okay, they only intersect one time. No solution means they do not intersect at all. There's no ordered pair that you could plug in to the equation that'll work for both of them. And the last one, when we talk about infinite solutions, just remember, it's going to probably be this, not probably, it is going to be the same line. So no matter what point you plug into the equations, is going to, all points are going to be true. But let's focus on the one solution so you guys can understand more of what I mean. So we're going to scroll down a little bit, get some space. As a matter of fact, yeah, scroll down some. So we have the ordered pair 2, 0. So x is 2, y is 0. And when we have one solution, what we're saying in the problem is, hey, once we plug this into the equation, it'll be true for both equation A or line A and equation number B, right? So let's go ahead and substitute. So now we have 3. We're going to substitute 2 in for x plus 0 for y. And we're going to say that that is equal to 6. So when we look at this problem, right, 3 times 2 gives us 6 plus 0, and this is equal to 6, right? So we could say that this is true. 6 is equal to 6. I'm sorry. Let's go back and put that in red because I just want to make sure it sticks out. So we know that works for the first equation. This is for line A. Now what we want to do is go ahead and do the same thing for line B. And basically, when it's one solution, we're saying that when we plug this point in for both equations, it's going to be a true statement, which we could see right now. So let's do that. 3 times 2 minus 0 is equal to 6. And guys, we're going to get the same exact answer. 6 minus 0 is equal to 6. We could simplify that to 6 is equal to 6. So the point 2, 0, or the ordered pair 2, 0, is a solution to the systems of equations. So thank you guys for joining us today on Systems of Equations. Join us next week when we talk about elimination and the substitution method. Thank you.